For the second semester CSE students, the basic electrical and electronics engineering subject, third unit is DC machines and transformers. The second module in the third unit is construction, principle of operation, characteristics and applications of DC generator and its types as well as its applications. The primary function of DC generator is to convert mechanical energy to equivalent electrical energy. An electromechanical energy conversion device or known as DC generator, which uses electromagnetic principles to convert the mechanical power into DC electrical. What about the construction of DC generator? The structure of DC generator looks like in this format. It consists of the field windings, pole shoes, tube, commutator, interpoles, armature conductors, as well as yeah. The construction of DC generator as well as DC motors, both of it. The various components present in the DC generators are yoke, magnetic field system, armature windings, commutator, shaft, pole shoes, poles, as well as bearings. Then we will see the working of DC generator. Here the armature is rotates in between the poles. Because of this rotation, direct current will be generated. If we are representing in a graphical waveform, we are taking angular reflection in the x-axis as well as EMF in y-axis. Means here initially it will generate AC only. After that, by means of commutators, it will be converted into AC. There are varieties of DC generators are available. If the permanent magnets are used, means that are called as permanent magnet DC generators. Okay, the field coils are energized by permanent magnets. The second category is separately stimulated DC generators. The field coils stimulated by an external source. The third variety is self-excited DC generators. They are having field coils. They are stimulated by the generator. Then we will see what is permanent magnet DC generator in a detail. This type of generator generates the flux in the magnetic circuit using permanent magnets. It consists of armature and one or more permanent magnets positioned around. This type of DC generator does not create lots of power. And normally, this type is used for industrial applications, which employs they are commonly employed in tiny applications like bike dynamos. The construction of permanent magnet DC generator will be looks like in this pattern. The second category, separately excited DC generator. These are generators with field magnets powered by an external DC source, such as battery. From the circuit diagram, here IA is equal to armature current, IL is equal to load current, V is equal to terminal voltage, AG is equal to generated EMF, which is nothing but electromagnetic. Separately excited AC generator. For its execution, separate the DC generator's armature is that the field windings are excited by means of separate excitation. From the diagram itself, we can understand the field windings are getting the separate source. The armature is connected, the load is connected across the armature. DC generators with self-excitation is nothing but self-excited, the third category, self-excited DC generators. These type of generators will have field magnets. They are powered by the current supplied by themselves. These type of devices, the field coils and the armature are linked internally. These self-excited DC generators are again classified into series type generators, shunt type generators, as well as compound type generators. What are series generators? Here, from the name itself, the windings, field windings, as well as the armature windings are connected in series with each other. Thickness, the number of the in series generators, the number of windings in the field are less number of windings, but the thickness of the windings are high. The second variety is shunt type of DC generator. Here the field windings are connected in parallel with the armature conductors or armature windings. The third category is compound DC generators. Compound generators use both series as well as shunt type of windings. One winding is connected in series with the armature, while the other is connected in parallel with the armature. How the armature as well as field is connected. Again, this type is classified in the short shunt compound generators as well as long shunt compound generators. What is meant by short shunt compound generators? Here, in the short shunt compound generators, we use the shunt field winding is connected parallel with the armature. The whole combination is connected in series with the field winding. It consists of series as well as shunt connections. The shunt field winding is connected in parallel with the armature. The whole combination is connected in series with the another set of windings. Long shunt winding means it consists of the shunt field winding is parallel with the combination of series field winding as well as armature. Then we will see what are the losses occurs in DC machines. In both DC motors and generators, there are a number of losses normally occurs. Some of the losses are copper losses, armature copper loss, field winding copper loss, brush contact resistance loss, core losses, which is also called as iron losses, hysteresis loss, eddy current loss, mechanical loss, stray losses. See the characteristics of varieties of generators. First, we see the characteristics of DC series generator. If we are taking the graph and between load current as well as voltage means, the open circuit characteristics is represented by the curve 1. The internal characteristics of the DC generator is represented in by 2. The third one represents external characteristics. Characteristics of DC shunt generators. In the case of DC shunt generators, the characteristics curve between IL and V looks like the first curve represents open circuit characteristics. The second curve represents internal characteristics. The third curve represents external. No characteristics of a DC compound generator is represented by the first curve is over compound generators characteristics curve. The second curve represents flat compound. The third curve represents under compound generators character. Then we will see some of the applications of separately excited DC generators. These types of generators have a ability to provide broad range of voltage output. They are commonly employed in laboratories for testing. The separately excited generators can maintain a constant output regardless of the field excitation. Because of these characteristics, this type of generators can be used as a power source for DC engines whose rates must be adjusted for various purposes. Best example is speed control system for ward layout. Applications of DC shunt generator. They are used to provide general illumination. Then again, it is used to charge batteries. They may be configured to provide consistent output voltage. They can be used to provide stimulation to alternators. They are also utilized as miniature power supplies. Applications of DC series generators. They are used to provide field excitation current in DC trains for regenerative braking. These generators are employed as boosters to compensate for voltage drops in feeders in a variety of distribution systems, including train service. These types of generators are most commonly employed in series arc light. Applications of compound DC generators. Cumulative compound generators are used for illumination, power supply, and heavy power service due to their constant voltage properties. They are primarily overly compound. Total compound generators are also used to power a motor. Level compound generators are commonly used for small distance operations such as power supply for hotels, workplaces, houses, and lodges. Because of strong demagnetization armature response, differential compound generators are employed in arc welding applications requiring a big voltage drop and steady current. These are all about the construction, principle of operation, as well as types, characteristics of DC generators. Thank you.